Hello, everyone. It's great to be here. Very nice to meet all of you. My name is Michelle Lee. I'm one of the members of the Filecoin project. We have been building a decentralized storage network, the biggest decentralized storage network in the world, built on top of the interplanetary file system. So I'll talk a little bit about Filecoin, IPFS, how those two work together, and how they link to other parts of the Web3 ecosystem. I'll cover some of the core concepts and the Web3 possibilities. Today, we're not going into a deep dive into the cryptography or economics, but happy to cover questions in as much time as we have together. And we have some hands-on tutorials that we link to, but I'm not going to walk through it step by step here today. So I'll keep an eye on chat and feel free to unmute yourself and chime in if there's anything else you want me to expand upon or no. So IPFS, has anyone heard of IPFS?
It's interpretation of like
yes, I've heard of IPFS.
Okay, great. It stands for Interplanetary File System. It's not a file system. That is a lie. It's a misnomer. But what it is, I think it's accurately described as a system of files and folders and a method of storing data that is distributed. So there's no central server, it's all peer-to-peer, and it's designed to be very resilient. So even more resilient than today's web, where 90% of internet traffic is routed through Apple, Google, Facebook, et cetera. And it's got a couple interesting technological underpinnings that I'll talk about in just a minute. I think the first one is this idea of the peer. So today, when you look up an IP address, it goes through the domain name service, and it looks up exactly where in the world that server is, and therefore like who might hold your file or your data, right? In a peer-to-peer system, turns that entirely upside down. So instead of having DNS servers or central authorities that you go to look up an address, instead we have the design of something called a swarm. And every peer in this network, every peer participating in this peer-to-peer network uses a cryptographic key pair for its identity and for encryption. And so it's got a unique name that's usually a long alphanumeric system, and it creates connections to any of its neighbors that it can find. So it goes around saying, hello, 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 this is my ID, this is the content I hold. And then when other peers want to look up data, it uses that map of peers to find the closest peer to the content that it's looking for. So these peers, these nodes have a couple unique characteristics. They've got a unique ID. They're connected to other peers. They have encrypted channels. They have ways of reaching each other, dialing each other using libp2p. The other thing that is included here in IPFS is this concept of content addressing. So, if you look in the middle of the slide, abc.doc, pic.jpg, file.txt. So typically your data gets a file name in the traditional web. In the content addressing model, we use a one-way hash function that creates a unique fingerprint or a content ID of your data. And then your data, it generates an entire tree or a direct acyclic graph that is the data structure where these units of data are tied together. So instead of giving each piece of content a file name or a specific location, it gets a unique fingerprint. The fingerprint is a way to identify whether your data, file 1 and file 2 actually contain the same contents. It makes for a lot of efficiencies in passing data around, or doing checksums or verifying if data came through correctly, or if the data that you're looking for has changed. And this is part of what allows this peer-to-peer network to thrive, because you're looking for CIDs. It doesn't matter what any of the peers have named your data or your file, right? So this is If you look on the bottom, it's a location. We're switching from a model of using a location-based identifier, identifying your data based on file name, to an IPFS identifier. So an identifier that's generated directly from the content that you're providing.
Michelle?
Yes.
Yeah, I just need to interrupt because I have a hard stop at 7. Question, will your presentation be available on the Meetup site?
Yeah, I will share this with Ranjo. And we'll
Yeah, I'm recording it, so you'll have it. I'll post YouTube after this.
You're the best, Banjo, and I'm sorry I couldn't stay later, but I've actually got a choir rehearsal at 7:30. So, all right, nice seeing you all. And
enjoy.
Good luck, Michelle. Thanks again. All right, bye-bye.
Thank you.
Bye.
Okay, so if we have this peer-to-peer network and all these peers are participating, they're just kind of joining the network to participate. How does it actually work in production, right? So how does your data stick around? Who's actually storing other copies of your data besides yourself? So you can run your own nodes. That's one model. You can run 2 or 3 or 4 or 5 nodes. You can run 100 nodes, but that's not very fun from a DevOps perspective. 2, you can hope your content becomes popular enough that other nodes will probably copy it, because it gets fetched a lot and it's kind of just floating around the ether. Maybe the latest episode of The Wire or something gets pinned very frequently, but that's also a strategy that only works for a subset of content. The third option, you can run your own network of nodes, and then you need a whole infrastructure to manage it. There's also a model where a lot of pinning services and essentially hosted storage providers for IPFS will pin your content on their nodes. So Pinata, Temporal, Infura are a couple of these storage providers. They do a fantastic job. But that is still paying a centralized company. And so, if you apply the principles of Web3 and of blockchains to this, isn't there a way to do this that is entirely peer-to-peer, that doesn't rely on any company to ensure that your data gets stored? And so that's where the idea for Filecoin came about. It's storage designed for Web3 from the ground up. So it uses IPFS as a building block to share all the benefits of content addressing and CIDs. And it integrates with a lot of Web3 networks like Near and Hedera, and a lot more coming soon. 2, it's verifiable. So all of your data and your storage deals can be confirmed through cryptographic proofs because they're stored on chain. And then you can always reference the chain for metadata about your storage deals. And then lastly, it's extremely decentralized. So it's hundreds of storage providers, no single company, and the entire protocol is governed by consensus. So there's no one individual making decisions or one corporate entity making decisions. It's governed by an open source process. Couple things. This is a diagram of how storage works on Filecoin. So first of all, usually it's the application that you're using, or maybe even a storage service that you're using to broker deals, make deals with a provider to store your data. And then Filecoin preps your data by transforming it into these graphs using the same exact process as IPFS. So if you've stored data on IPFS and you get a CID, that CID is the exact same CID used in Filecoin. So that allows for a lot of designs where you could have used both systems, one as a hot layer, one as a cold storage layer. The second thing that happens is once the provider gets your data, they generate an initial proof of replication. That means they prove that they can have a copy, and they include that in the storage deal that they publish to the blockchain. So once the deal is committed to the chain, the provider has put down some collateral, and then the funds that you as a client provide get paid out to them over time. So over time, the providers have to keep proving that they have subsets of your data still. You're creating these proofs of space-time. They have to generate them every 24 hours, and also sometimes randomly, depending on when and how they're selected by consensus. And they're paid incrementally for keeping up with the storage deal. And when it's time to get your data back, you make the same kinds of deals, include CIDs. You basically negotiate through the protocol with providers to get your data back to you or back to whatever location you want to send it to. And at any time during the storage deal, you can check the chain for the proof that it's being stored and stored correctly at any time. So like I mentioned, because of the shared CIDs, because of the peer-to-peer networks, you can think of this kind of like two-layer solution where IPFS are the green blocks. They have fast and flexible retrieval. There's a lot of stuff built into the, into new Web3 applications. For example, the Brave browser supports IPFS natively, and then a lot of other browsers were working on getting them to support IPFS either natively or through extensions. And then Filecoin is where you have persistence and the ability to verify that storage. So the two work together hand in hand. And Filecoin being both the name of the protocol and the name of the whole network, there's a lot of different layers to it. As developers, I think these two kind of in the middle are the most interesting. One is a whole set of services or hosted APIs, and then another is developer tools and libraries. You can see here's some stats on the network. It's already out of date. This shows that we're at 8 exabytes of data. The network actually just crossed 10. But you can see, the way storage power is distributed is very, very broad. That big blue block with 3/4 of the pie chart is actually providers that are too small to be named. And then the rainbow slices are, specific storage providers that are big enough to show up on the graph. Right? This all means that we have a lot of really great foundation to build Web3 style apps. In a normal application architecture, you might have like a front end, and then you have application logic, which is orange, and then you've got the yellow layer, which is the storage and data models underneath that. In this Web3 model, the front end can include classic web apps or data solutions that speak to blockchains, but it can also include like fully Web3 apps where the front ends are hosted on IPFS. The product or the company's business is built around Web3, such as NFTs, on OpenSea or other decentralized apps. In the second layer, the orange layer, you can have pretty standard application logic, but that's also where smart contracts come in. So you can build in logic and trigger different events depending on however you've set up smart contracts. And then these smart contracts can actually read data from other parts of the blockchain or Web3 ecosystem. So some smart contracts kind of use things called oracles. Chainlink has created a whole network of oracles that basically allow you to check Web3 for data and then use it in, check Web2 for data and then use it in Web3 systems for contracts. Any of these can also use decentralized storage layers. So the fun looking logos in that yellow box are some of the services that make it really easy to store data on IPFS and Filecoin. And I'm going to talk about those in a minute. This is an example. Sorry, go ahead.
No, yeah, hey Michelle, I wanted to ask. I'm a sysadmin myself, and since you brought up like the overall infrastructure, when I'm like a normal user just browsing the internet. Do you guys plan on supporting HTTP? Like your standard serving up web pages in a decentralized way on your decentralized network?
Mm-hmm. So I think IPFS, I would think of it as a parallel to HTTP. So HTTP asks for, hey, that thing you've stored at this DNS address, and IPFS asks for this CID, the stuff that is represented by the CID. I don't care where it comes from. There are things called gateways. So basically, a service that takes any standard URL and then translates it to an IPFS address. And so that's how most likely, if you go to, let's say, a website like fleek.co, fleek.co, that's a fully decentralized. Actually, this example on screen works too, app.uniswap.org. So this is a fully decentralized web application, but the gateway allows your browser to understand, or the gateway is what allows your browser it allows you to type app.uniswap.org in the browser. The browser, uniswap.org is actually part of the IPFS gateway, and then it's loading content through that protocol instead.
So to the user, it's seamless. The difference between an IPFS server and a standard AWS server, that to a user, it's seamless. There's no difference to the user, is what you're saying.
Yeah, it can be. You have to kind of build your app and set up domain name routing and things like that. If for standard browsers, with the Brave browser, it's entirely seamless because that supports IPFS from the get-go. Chrome also has an extension. It's called IPFS Companion that lets it do the same thing.
That's cool. And so you plan on making it for all browsers at some point, correct?
Yeah, that's the goal for sure. So Mozilla has approved IPFS as a format in its upcoming I forget the name of where it was approved as a standard. It hasn't been implemented yet, but it's now on the list of approved protocols that it supports, which is amazing progress. And then hopefully in the future, we can actually get that built into the browser itself.
Well, how is the performance for like web pages? I mean, how would the performance be?
So there's some really cool research projects that indicate, especially if you're doing compute on the same machine as your IPFS formatted data, that can be faster because the CID structure allows it to process or manage like data IO a little bit faster. The other thing that's great with IPFS is it's more resilient. So if there's slowdowns in the way traffic is routed around the web, IPFS will just grab it from the closest. So it's essentially performs similar functions as Cloudflare does for today's web, but it has even more options when it comes to which peers it might pull data from.
Wow, that's interesting. I didn't know that at all. That's fascinating.
Yeah, the design, I think the design of it is really, really exciting. It allows for a lot of efficiencies. When we're just in the early days of this, right? So a lot of it is dependent on how the app is architected and, how just the specifics of the networking, situation. But there's a lot of potential for this to be more efficient, both for folks like us that live in places where we can use Zoom regularly, but especially for people with less reliable internet access.
Sure.
Okay, let me go back to this really quickly, because for developers, there's especially this past year, there's a suite of really great tools that make it easy to build on IPFS. Probably the easiest way to start working with IPFS, you almost don't see it because they make it so easy, is to use Fleek hosting to deploy your site, a copy of your site onto IPFS. So the way it works is you just connect your GitHub or GitLab or Bitbucket repo, add some build settings, and click some buttons, and it deploys onto IPFS. So it makes these websites work really smoothly. It's compatible with basically any modern web framework. We use it for all of our Protocol Labs websites and Filecoin project websites. Really, really simple. But if you're actually interested in playing with IPFS, this doesn't do a whole lot for you because it makes it so seamless that maybe it's not fun if you like to poke around. So another set of tools to think about is storage helpers. So if you're going to be storing and retrieving data from these systems, we highly, highly recommend you choosing a storage helper. So most people hear of Filecoin. Filecoin in particular, I think IPFS has on its own has certain ways of building it into apps that are also pretty easy. But if you want to use Filecoin at all with the verified storage, really recommend storage helpers because they smush everything into a single API call rather than like 8 or 9. So Fleek is an SDK designed for building desktop apps. It runs on the user's desktop, so it sort of bundles an IPFS node into the desktop app that you're writing. It's got a gPRC API, JavaScript client. Estuary is another service, and this one's written by one of the core devs on both IPFS and Filecoin. So it's optimized for really high performance storage needs. They've got really seamless deal making and verification. You can see in this like colorful chart is a display of how you can track your data and storage deals, and then you can also access this through APIs programmatically too. And it'll automatically choose 6 providers around the world, store copies of your data for you. Because of an incentive program called Filecoin Plus, where we've reserved tokens specifically to reward storing what we call like data that's good for humanity, or like real data. Estuary, currently using Estuary is free to store, and it will be for a long time into the future. So really cool tool to experiment. There's a web interface, but I think more interestingly, and the vast majority of its usage comes through the HTTP API. They have great docs too, and on the Filecoin Slack, which I'll share the link to, the team is super responsive.
I got one quick question, and then you can continue the presentation. Do you plan on also, I see that you support Docker. Do you also plan on doing integration with like Kubernetes as well?
I think that is, widely acknowledged as a great system, great kind of ecosystem to integrate with. I don't know the details of when that might be coming. I think some of the focus right now is just kind of listening to the community. So if that's of interest, show up on the Slack or show up in the GitHub repo, please, and file some issues, making your interest known.
Will do.
Right.
Another one, I don't know if anyone here likes building NFT apps, but NFT storage is a really great service. It's designed specifically for NFT developers who want free decentralized storage. So again, using that Filecoin Plus system to basically sponsor or incentivize storage of data like this. You make single API calls to upload your data, you get it back, the CID of your content, and then you can use it in smart contracts or chains as a pointer to your data. And it's also a way to ensure that the underlying NFT has not changed. The really nice thing about using this, if you're working with NFTs, is that you get nicely formatted metadata back. So this is a great tool if you're working with NFTs at all. The same team has actually just come out with a service called Web3.storage that is similar, also has a JavaScript client library, HTTP API, and also is making storage pretty seamless. That service actually uses Estuary back here. So you have some options like these the .storage tools are a little more tuned to JavaScript developers specifically. And then Estuary is pretty agnostic because it's just an HTTP API. Another one to be aware of is Powergate. So this is, I would call it like a more low level, more powerful tool. It's a Docker container wrapped around an IPFS and Filecoin node. It lets you stage and store and retrieve data. There's a lot of configuration options. So some of these tools just choose how many copies they make for you, 3 copies, 6 copies, whatever. Using Powergate, you can configure like anything your heart desires. So probably a tool to use if you really like digging into the weeds. This team has also been building bridges to Near, Ethereum, Polygon, lots of other Web3 systems. So they're doing really cool work, and recommend looking into it if you want to work a little closer to bare metal. And I think they have both JavaScript and Go clients. That's that. I'll wrap up that tour of different storage tools. If you're interested in working with or trying out any of these, there's a number of docs available. There's some resources for learning. We also have like 1 million hackathons going on. I just wanted to let me pull up couple particular initiatives. The first is that we have a really robust grants program, and there's 2 particular grant types: Next Step microgrants and open grants that I would love to make sure you're all aware of. The microgrants are grants of $5,000 in Filecoin that are available to support taking the next step after you've started your project with either IPFS or Filecoin. So they're intended for independent devs, small studios, nonprofits, activists, researchers. They're really intended for early stage projects. So the criteria for this is very, very simple, and you apply through filing a GitHub issue. You can even see some of the accepted proposals here. We've got even more in the IPFS repository, and that's a great way. Basically, all you have to do is show that you can build an initial prototype, or you've started work, you've got something running, and you want to take it to the next level. So that funding is there. The other is that we have an open grants program for larger projects to support new ideas that advance the ecosystem. So these applications have a little bit more structure to them, and they're evaluated based on the quality of the proposal. But in both cases, we evaluate the microgrants on a weekly basis, the open grants on a monthly basis. So our goal is to make this a really great on-ramp for building in the community. The last thing I'll share is that filecoin.io/Slack, and you can also find the link from our website, leads to our Slack, which is also bridged to Discord or Matrix. You can choose, pick your poison to connect with us. And there you'll find a few different channels for people where people who are building on top of these systems can come together and chat. You can post questions, find some community office hours, basically get technical help figuring out how to work with these technologies. These are the two links. I'll make sure they're posted to the meetup page as well. All right, that's the end of the presentation. Thanks for those of you who came, and happy to turn it back to you, Benjo.
Sure, I can ask a question. I know with IPFS, once you put something there, it's there forever. So can you talk about, like, if I wanted to update a file, okay, how does that kind of work in like the IPFS Filecoin ecosystem?
Great. So yeah, exactly. Like it's a double-edged sword to have the CID permanently tied to the contents of the web, right? So we came up with another great acronym called IPNS. It's called the Interplanetary Name System, and it basically is a system for aliasing your CIDs so that you can change, you can update your content. I shared the link to the docs in chat. You can update your content, but not have the IPFS address broken. And you still want to preserve that CID connection to the data. So there's a system of public-private keys that are used to update the IPNS address.
So that's kind of like your own internal DNS, is what you're saying. Pretty much, yeah.
In that regard, is it possible to remove content once it's been pushed, or how does that work?
So if similar to the web today, if someone else makes a copy of your data, you don't have control over it anymore. I think the main ways you would control that are to, one, encrypt data that you might want to take down, two, stop. Two, you can, if something's violating legal agreements, for example, you can contact the gateways. The gateways maintain denial lists, and so that's a way to prevent, a significant portion of traffic from accessing this content that you don't want to have out there. And then you can, of course, you can remove it from any peers that you manage as well.
Michelle, can I ask you a question?
Sure.
How much does it cost typically, like, to store something? Like, I'm thinking in terms of NFTs. People have these very valuable NFTs they spent, well, we've heard millions of dollars for. And if they want to store the data itself for the NFT on IPFS, how much does it typically cost to make sure that it's there forever using Filecoin? Or I just wasn't exactly sure the role of the cost for your storage.
Mhm.
you know,
Yeah.
on something like IPFS, which I thought was sort of free, but you're saying it really, you know, you want to guarantee your NFT is going to be, you know, it's going to stick around.
So there's I think of NFTs in two parts. Like one is the metadata around the NFT, like the issuer, you know, which wallet controls it, you know, file size, all these aspects around the NFT. And then the NFT itself, which, you know, for an image file is not that big, but you can really create NFTs with any sort of underlying digital asset. So you could have a video file or a sound file. So for the vast majority of NFTs, only the metadata gets stored on chain, and the NFT itself is stored in a different way. What we're saying is, if systems store, you know, if NFT issuers store those NFTs on IPFS, it creates a CID that makes it a lot more reliable to, you know, to guarantee what the underlying asset is. So your metadata goes on chain, and then the contents of the NFT itself don't have to live on chain. They can live in they can live in a system of your choosing, but then you can actually change the underlying file that your NFT points to, which is not, you know, kind of violates the whole point of NFTs. Or you can store it on IPFS, which generates this CID that you can use when you publish, you know, transactions or sales to the chain.
Okay. Thanks.
You were asking about costs too. Sorry, I went on a big tangent there.
Yeah, no, that was fine. That was fine because there's a lot I don't really understand about this. But yeah, well, the cost, like Filecoin, I'm not sure the role. How does Filecoin play into this? If you want to, let's suppose I want to mint an NFT and I want to store it on IPFS somehow. Do I need Filecoin? Or how much does it cost to use Filecoin? Is it a one-time cost? You know, like it could be stored there for years. Is there a continual cost? I just wasn't sure how that worked.
Yeah, so the way the protocol is designed, you make storage deals with provider, you know, at the atomic level, storage deals are made with providers for a certain amount of time. The deals expire, you know, etc. But most of the storage provider services that we're recommending, all the ones that I showed, actually take advantage of an incentive program called Filecoin Plus. So Filecoin Plus basically rewards providers I think their reward is 10 times larger for storing quote real data than fake data. And so using this incentive program is what all those storage helper apps use. So to the end user, the storage is free. And unless you get into really astronomical quantities, you can take advantage of these services.
I see. Great.
I guess one way to look at it, like if I was developing like a Web 2 app, I would use Amazon S3 and I'll just post something there, but I can always change the Amazon S3 link, but now I can use something like nft.storage to just put my metadata there, and then that's basically the equivalent of Amazon S3. I'm storing a JSON file on a cloud somewhere.
Mm-hmm.
Does that make sense?
Yeah.
Hey, Michelle, quick question. The surge in Bored Ape Yacht Club, are they bullish on Filecoin?
Sorry, I didn't hear the first part of what you said. Can you repeat that?
The Bored Ape Yacht Club, I'm sure you've heard of them, you know, the whole thing with the NFT Bored Ape. Are they bullish on Filecoin?
The Bored Ape Yacht Club, as far as I know, they use IPFS to store the apes themselves, and then I don't know what chain the all their contracts are written on top of, but I think
They use IPFS, but yeah, I don't know.
yeah, again, like they don't have the big, because they're basically just storing image files. They don't have like really large scale data storage needs that Filecoin would be really good for.
Gotcha. Last quick question. Since through your presentation, we all know that storing data on Filecoin is not free. If you don't mind me asking more of a direct question, like let's say I just want to store like images, like I want to make a Flutter or whatever, and I just want to store images using your service. How does using your service, as far as just cost, like per month, compared to say, like your standard centralized service like AWS or Azure or Google Cloud?
So the way the network incentives are designed, storage for projects like that is free. So you're comparing. Of course, there's like CapEx to implement and integrate and build out your application, but the OpEx is essentially zero. So there's no storage bill to you if you use a storage if you use a service like Web3.storage or Estuary.
Oh, I look at it, looks like, yeah, using these things like NFT.storage, you don't really interact with Filecoin per se. Like I'm just storing my JSON or image file. I don't need to like buy Filecoin or anything. I'm just going to utilize the service that's using Filecoin in the back end, just like about using Amazon S3. They have their data centers, which is doing all the stuff in the background. You're just uploading a file.
Exactly. It's like a broker that manages all the deals for you. It also essentially pays all the fees are paid.
So if you don't mind me being bullish on at least IPFS and IPNS, is if I were trying to do something like in a DevOps way on IPFS, as a business owner, I could basically develop my infrastructure using your decentralized cloud and have a zero monthly cost. At least that's what you're saying the potential is, as rather than having to pay. I mean, anybody who's played around with cloud knows that sometimes you're charged, even though it's 2 to 3 cents, you're charged by the hour, and that doesn't take very long for you to have like $1,000 bill just to set up a lab, even if you're just doing something like AI with TensorFlow, right? And next thing you know, your bill's skyrocketed just to build out some data models. And you're saying, again, which is what makes me excited about Filecoin is if we want to build this decentralized cloud, your competitive offer is we're free until the end of time. Is basically what you're saying. Is that it?
Yeah, I mean, certain very, very large scale storage clients are going to start paying into the network, right? But for any sort of like, exploratory, experimental usage, and that I think that's like much broader than most free trials or most free tiers are. We basically allocated a huge portion of the storage capacity on Filecoin to storing real data, real projects. So yeah, I think the really interesting things coming up are for the developer and operator ecosystem to mature the same way that the cloud native ecosystem has. So, databases and ML platforms and all of that stuff, building those in a Web3 native way will make it a lot more appealing for projects like the ones you described to just jump to Filecoin right away.
Yeah, but it seems for now, Filecoin is just storage. It's not compute. Like I can't run a Docker image on a Filecoin. Basically, I'm storing metadata, static images, not like you just mentioned, like AI. I'm not running actual compute workloads. It's just storage workloads right now.
Yeah, you can run your compute workloads somewhere else, but then pull all your data from IPFS and Filecoin.
Do you guys have any plans for any compute protocols? Because on AWS you have EC2 that allows you to do your compute, whereas they also have EBS. No, I'm sorry. Elastic storage. Yeah, EBS. Am I right?
Yeah, you're right. That's elastic block storage.
Yeah, I mean, all of these things need to come to Web3. So if you want to build a business around this, we have dozens of investors who want to support new businesses in Web3 doing things like this.
Of course, with EC2, you have the Ethernet virtual machine. I mean, the the EVM. In theory, that's what the, Ethereum is the world computer. But anyway.
Wait, EC2
EC2 is the Amazon
Amazon, right?
service. Yeah, it's they say virtual machine in the cloud.
There's also ETH2, which is maybe where the names are shared. Is that what you're talking about?
Well, when I think where the confusion here is, and if you don't mind me kind of clarifying, so when he says the EVM, Ethereum virtual machine, that's a little bit different because that's only meant to run your smart contracts. Right. Whereas like if you have EC2, that is like your own virtual environment where you can basically set up services and you know, do all kinds of things. I mean, you can have anything from like, I think like Try to Hack Me is using probably AWS, and I wouldn't be surprised if they did, to, you know, Netflix is using AWS, and they're all doing it on, you know, EC2 if you decide to go with Amazon. So, you know, to kind of like crystallize what we're kind of discussing here, which does bring an interesting opportunity, is the fact that, you know, it'd be fascinating to be able to, you know, have like an actual Docker container established within your ecosystem, because I see that you support Docker, but to be able to have like a Docker instance in your IPFS protocol would be, yeah, that would be game changing, because it doesn't cost me anything per second or per hour to do that.
Yeah, I think Ethereum smart contracts are not used for high speed or high throughput types of computing. It's really almost like, think of it like as a notary, like however often you register documents with a notary is about how often people want to publish to the Ethereum main chain. But I think just what you're talking about, like everything that you could do, everything that people do currently with compute and EC2 would be really amazing to bring over to Web3.
Agreed. I'm excited for the future.
What kinds of projects is everyone working on, you know, either for your primary time or your spare time?